That's the only thing. Then after you do the calculation, should be B. Okay, guys. Should be B. Everybody agree?
Yes.
Okay. Then the question number 9. In this case is what is the transmission delay for this packet? Still L is what? 1200, right?
Yes.
Should be 1200 multiplied by 8 divided 100 megabit per second. Mega is 10 to the 6. Makes sense? Giga is 10 to the 9. Okay. In that case, this one should be should be A. Okay, just get used to those basic calculations. Still, we are talking about what? Transmission delay. Transmission delay L, and also only one node transmission. L divided by R.
Yeah.
Okay. And then next one. Next one, I was asking, what is the transmission delay at link 2, right? Still very simple one. So they are testing your understanding regarding to the different delay. They are asking your transmission delay. In that case, they may give you extra information. You don't need it. Make sense? So for this one, transmission delay, what do you need? You need information is the transmission rate is 100 megabit per second, right?
Yeah.
And then what is the L? L is 8,000 bit. So in that case, it's 8,000 divided by 100 megabit per second. Got it? In that case, this should be C. See, you guys are pretty good. And then the next one is asking you propagation delay, right? Still, I've asked a link 2, but ask your propagation delay. So propagation delay, the formula for propagation delay is what, guys? Distance divided by S, which is the propagation speed, right?
Yeah.
And in our case, propagation speed, propagation delay is 3 multiplied 10 to the 8, right? And in this case, we need the link length here, 1,000 kilometer, right? So the denominator is 1,000 kilometer, basically it's 10 to the 6, right? Divided by 3 multiplied 10 to the 8, okay? In that case, it should be B, right? Basically, just directly following the formula to the calculation, that's it. Just you need to pay attention what they are asking for. This one is talk about the throughput, right? What is the maximum throughput achievable between sender and the receiver? Make sense? We have a sender and a receiver. We have 2 links, 2 hops in between. When we talk about the throughput, we need to take what? We need to consider the bottleneck, right? Right? Since in that case, this one is 1.5, this one is 10. So when you try to send something, you are limited by the thinnest pipe, right? So in that case, this throughput should be 1.5 megabit per second. We need to have the bottleneck concept. This is B, great? Okay. So 13 is still playing with the throughput concept, okay? So what is asking? What is the maximum achievable end-to-end throughput, right? That's what's asking, right? In this case, what is the setup? We have the network core, we have a server, and we have a client, right? So for each link, we have a server part, the network core part, and the client part, right? Remember, when you watch the video, the formula, you have to take the minimum of those kind of link transmission bandwidth as your throughput. That makes sense? In this part, your server part is 50 megabit per second, and your client is 90 megabit per second. And the middle part, assume everybody is the same. Basically, 300 divided by 4, right? Which is 75. So in that case, what will be the throughput along this path? Take the smallest. So the answer would be 50 megabit per second. Okay? Right? Got it? Okay. Then, when you graph the corresponding throughput, then sometimes when the pipe is flat, right? The pipe is only half full, right? Makes sense? Then what is the utilization rate? It's depending on how audio pipe is a corresponding channel. That's basically the concept of a utilization rate. Make sense, guys? Okay. So in that case, for question 14.
Sorry, that question 13, what did you pick?
50. Your answer, if I have to put here, would be 50 megabits per second.
Okay.
Because you take the minimum one. That is everybody fine? Okay, next one. Next one, that question asking is same thing, right? Assuming that the server are sending at their maximum rate possible, what are the link utilization for the server link? Make sense? That's what's asking. So actually, along this path, the server part is the bottleneck, right? If server is sending at maximum rate, basically these are sending at 50 megabits per second. That's the rate, right? Mm-hmm. Then the server link will be full, right? 50 available is 50 megabits. I'm using 50, so utilization rate would be 100%. Would be 1. Make sense? That's basic. All software can be so aggressive. So this one would be 1, right? Makes sense? Utilization rate would be just 100%. I'll just put a 1 here, okay?
Because it's maximum, that's why it's just 1.
Because they have an assumption is the server are sending all the maximum rate possible. Basically, that means they are sending at 50 megabits per second. And that means this link is full. Makes sense? That's the ideal scenario. In reality, that's the case. They will have a congestion. Okay, that's it. That's the idea. Just playing the game. Okay, second one is still assumption is the server are sending at the maximum rate. What are the link utilization of the shared link, right? Right. So in that case, remember the throughput, because this is 50 is the bottleneck, and the middle part maximum you can pass is still 50 megabits per second. Then the shared link is basically each one is 50. The total pass is 50 multiplied by 4 would be 200, right? So in that case, it's 200 divided by 300. So this one would be what? 0.66, right? 0.67 to be exact. Make sense?
Yes.
Okay. That's basically for those kind of shared network core. For this link, the utilization rate is 0.67. Okay? Everybody okay, right? Okay. The next one, so those are all very simple. Then ask you for this link, what is utilization rate would be what? So your throughput is only 50, right? Your available bandwidth is 90. Would be 50 divided by 90. So this one would be 5 divided by 9, right? You can do the calculation. Make sense? That's it, right? So easy. Everybody, we can pass. Finally, I don't even say it. So remember, guys.
Excuse me, before you move ahead, how did you get the line? You divided 5 by divided.
Because for the client side, your bandwidth is 90 megabits per second, and the throughput is 50 megabits per second.
Oh.
That's why it's 50 divided by 90.
Okay. Thank you.
I just close. Next time, ask me before I close that document.
Thank you.
Because the software is not friendly. Okay, guys. Still, this section, remember I mentioned we have a few really important concepts, right? I still quickly ask you. For the performance, the author mentioned the loss, delay, and throughput, right? For somebody who already have some kind of networking experience, those loss, delay, and throughput typically we call them what? For network terminology devices. Okay, anybody?
What was the question?
For loss, delay, throughput. When we talk about the network performance, we typically give them a terminology. They are called QoS, right? Typically, when we mention the QoS, that's all related to this. What's the corresponding loss? What's the throughput? What's the delay? That's what care, right? For the different network application, they care. If, for example, when we're doing the streaming, if the delay is too much, are you happy?
No.
For the streaming, when you have some loss, are you okay? Really? Oh, you guys are so picky, you cannot get all, right? When you're doing streaming, when you're watching a movie, when you have a certain loss, sometimes it's have a little bit of jumping, you are not fine?
No.
Okay. Now then, next one. When you are doing the banking, you are putting money in your online banking. When you have some loss, are you okay? Know the difference now, right? Makes sense? So that's basic, depend on different network application. The QoS you cared about, of course we care. We want it smooth, but it's not that important. Make sense? If you're doing some kind of online banking, if you have a little bit of loss, are you okay? Of course not okay. Even when I send you an email, when you have some loss, are you okay? Maybe that email carry very important information. Okay? Got it, right? That's called network quality of service. Besides those loss, delay, and throughput, what else, guys? When we talk about the typical QoS concept, speed is related to throughput and delay, right? Kind of, makes sense? Reliability. Reliability is related to the loss part and the delay part, right? First, guys, for each node, 4 different delays, everybody is clear, right? Even the definition part, transmission, queuing, processing, propagation. Then for those kind of delays, for corresponding formula, you are clear, right? When you're trying to do your homework for different scenario, play with those. So for those 4 delays, 4 different delays, which one is kind of could change dramatically? More like a variable, not like a constant.
Transmission.
Transmission is L divided by R, right?
Yeah.
For example, when you pay your SP, basically your link, the R is set, L is set.
Yeah.
Make sense?
Mm-hmm.
How come it will change dramatically? You know my point? You need to understand for each delay what's corresponding characteristic, right? You ask yourself, do you really know each delay? For your propagation delay, D divided by S, right? Distance divided by propagation speed, right?
Yeah.
It's relative when your distance, when your those kind of, the channel, what kind of link you're using. If you're twisted line, typically propagation speed is settled, right? When you're using satellite, it makes sense?
Mm-hmm.
So which one is relatively variable? What?
Propagation should be very.
Propagation is dW by S, right?
Yes, because sometimes the distance.
What is a variable? It's more like could based on the different scenario could change. When you settle on certain link, your distance is settled. The channel is settled. Basically, the physical medium is settled. Then, when the scenario is settled, you're settled propagation delay. Agree? Guys, remember, when we talk about packet switching, right? It also have we cannot guarantee anything, right? In that case, we could have what? When the network is kind of congested, they might have what? They might have lots of congestion. In that case, the router, the queue could change, right?
Okay.
When it's congested, the router's queue could get really long, right? Think about it when you later on when you go back home, 290 will be relatively empty.
Yeah.
You're happy, right? But when you travel here, 290 could be what? Could be really crowded.
Yeah.
Queuing delay.
Queuing delay.
Makes sense. Queuing delay is what depends on your network.
Okay.
You guys remember the traffic intensity concept explained, right? That means queuing delay is subject to your network congestion situation, the delay will change. It's more like a variable. Make sense? That's basically you understand each, but you need to actually understand, right? Guys, remember? Each node, see I put a nodal delay, that's for. Then, and remember ask me how the router handle the process, right? That's related to the process delay. How the router handle process each kind of packet. How the router will send from input port actually schedule for the output port makes sense. That's also router need to check each head packet header to make the decision. That's all the process makes sense. That's router. Then transmission, I think everybody is clear with this, right? Definition-wise. If you have questions, just stop me. Otherwise, just repeat because you already watched the video. That's basically talk about the queuing part. You guys remember this is depends on this traffic intensity concept. If your network is kind of congested, makes sense? If everybody is checking the network, the queuing will delay to the volume. Checking this part. When the network is kind of relatively not that busy, right? Then everybody is fine. When it reaches certain kind of limit, the queuing delay could get very significant. In that case, when you as a network architect, when you design your network, you will try to not make your network overloaded. Otherwise, the delay would be too excessive. It's like the scenario, your average rate is already about remember the example we played. We have 10 megabit total bandwidth. We have 5 users. If each user's average rate is already over the 2 megabit per second, that means it's kind of overloaded. Makes sense? Makes sense, right? If it's overloaded, that means it keeps constantly. It's not like for short term. It keeps sending those packets out. That's basically that scenario. Okay. That's for the queuing delay part. Then another thing I want to, that's what question I'm asking. It's more like a statistical issue. If you are measuring EE, typically we have lots of queuing theory handling those, what kind of queues, how to handle those kind of delay. Okay. For here, no. Then they also mention the trace route. Please play with the trace route. You can trace route like to some popular server like Yahoo, Google. You could get the first response like what's the corresponding delay, right? Typically, all those routers were blocked out. Then you have all the stars there. That's basic. Then for the trace route, play with those. Then who knows for the trace route which kind of packet the protocol is based on? I just wonder who already have network concept here. Remember, when the author play with the trace route, every time they have a stream packet passing through from first hop, they will return with the RTT, right? Tell you, then round trip time. You guys remember when you watch the video, then the second hop, they also tell you what's the corresponding delay here, right? The author's point is trying to when you go through really long distance, the propagation delay could get significant. Makes sense? Similar case, when we talk about satellite communication, those delay is also getting significant. Okay? For trace route, whoever knows the trace route, which kind of protocol is based on? Who heard about the SMP? For the network layer, typically we mention the IP protocol, right? IP version 4 and IP version 6. Then they have another companion protocol is called SMP. They basically tell you what kind of your network current situation, error reporting and checking. Makes sense? You guys also remember we have a hops, but you play with your IP packet, right? You have multiple hops there, right? When the hop, every time when you went through the router, the hop count will reduce by 1. Makes sense? When you reach 0, basically that means you need to throw that packet out. Makes sense? We try to avoid those infinite looping here. Makes sense? That's basically when we design this trace route, what we design is we send out the first 3 packets. We only put the hub as one. When you reach the first router, you deduce the 1, then you generate 3 error message back. Then you know the corresponding round trip time. Second batch, you put that router as 2. That's why when they reach the second router, it's reduced to 0, then you generate the error packet, then you can calculate the time. Makes sense? That's just to take advantage of the SMP protocol doing the trace route part. Okay, just later you have time with the network layer. That's why you can do those kind of statistics. But typically many routers just block this function here. So kind of okay. See, if you're interested, you can check corresponding RC regarding to details. Now, talk about the delay, right? So each node we have 4 different delays. Make sense? Then now if we want to talk about end, I already mentioned that in my case is I'm sending stuff to Israel, right? When I'm going to ask you the end-to-end delay, then that means what? We might have a middle end node there. Makes sense? You will calculate the actual delay from the client. C means client, S means server. Okay? You need to consider each node delay. In order to make things a little bit easier for the propagation delay, because distance you just add it up, right? The other part you handle for each node, you calculate it differently. Make sense? Then another concept is we later on we use constantly is RTP round trip time. Because think about when we first class we talk about the network protocol, right? We're using human protocol as an example when you ask your question, right? You need to answer, right? Similar case for network, we have a request, the server need to reply. In that case, it typically is a round trip, right? Then, of course, we care about round trip time. How long does it take? I send you a request, got a reply. Okay? That's the concept of the round trip time. Okay? The delay from client to server and delay from server to client. Sometimes the server you need to process corresponding information there. Makes sense? And just when you handle the 4 different delay, just pay attention. It's only local delay, the nodal delay. When you consider the end-to-end, you need to consider the big picture concept. That's my point. Make sense? Let's talk about the delay part. The queuing delay we already mentioned, right? Then, like I mentioned, when we talk about network, the quality of service is, when we talk about network performance, is really, really important. Finish our question. Besides delay, losses, throughput, what else? What else, guys? Anybody talk about the QoS? Who ever heard about the jitter? Here. You heard about it. Who heard about it? Nobody? So basically, think about the network, right? Client and the server. Think about it. For example, we are doing some streaming. When I have streaming, we have multiple packets. If your network is kind of not a steady situation, first packet, the delay is 10 seconds. Second packet, the delay is 20 seconds. Third packet, the is 50 seconds. Do you like it? Especially if you're doing some kind of application, for example, you're doing the streaming part. Some of them do not like loss, even the streaming part, right? You're doing the streaming part, if the delays keep changing, when you're watching those kind of, when you're watching those videos, it's kind of a jumping, right? Make sense? Make sense? Do you like it? Not, right? So basically, what is the jitter? It's a really important transmission of streaming in the multimedia application, streaming audio and video. Basically, we talk about the delay, end-to-end delay. We want the delay to be relatively constant. we do not like the delays. If all around 20 seconds, it's okay. Basically, send your something smoothly play, makes sense. Or 10 seconds, as long as it's kind of a constant, it's okay. The virus is small here, okay. But it keeps changing. Then sometimes it may cause a problem on the streaming situation. Makes sense? Because the variation in the delay part, the total delay, if it's narrow change, is okay. That's the jitter part. This is another kind of talk about the network performance, specifically talk about streaming, we care about this. In that case, we need to smooth it out, right? Makes sense? Otherwise, when I send you a certain rate, some packet come quickly, some packet come slowly. When you watch it, it's kind of, change the speed. Your experience may not be that good. Makes sense? That's basically talk about variation in network delay called jitter. Together, typically, when we talk about the network performance, QoS part, that's some kind of important metrics there. Okay. Okay. Now, next section is the security. Could you watch this by yourself?
Yeah.
I will quickly explain it here, okay? Because we are almost time. Not yet. I think our department has a secure center for quite a few secure class, right? Security related class, you guys can take it. Then we have a denial of service, different kind of security in there, okay? One thing is, talk about sleeping. Like sometimes when I send you something, there's a middle guy trying to sleeping something, right? You guys remember in the first class I mentioned what? Because for this we have too much material. If you're interested, please download this software.
Oh, Wireshark.
The Wireshark, basically what the Wireshark is doing, just doing sleeping part. When I send out something, just catch the packet. You download this when you start down. For example, when you send me an email, start catch this packet, then later after a little bit, just stop it. You will see the trace, what kind of packet goes through those. You will see lots of some link like TCP, IP, you will see it. You will see the layering concept. Some packets you have no idea. Because when we talk about the network, there's so many different network protocols. Many are proprietary reasons, but you got the sense. The reason I mention this is because Wireshark just add this, cache this packet like a sleeping, like the security button to catch whatever is now catch. Okay, that's play this by yourself. I will not physically give you homework, but just if you're interested, it's kind of a very free network analyzing tool. Because when you learn it, you will check what actually happening there. Okay.
Sorry. So the video for the security, the link is not in the slide.
Pardon?
The link for the video.
Of course, it's my slide. The slides I posted, but the link, if you Google, the slides I'm using is my slides. The slides, sometimes I'm lazy. I do not want to put it there. I put some sample there. I'll keep changing. Makes sense? The link, if you think about, I already put some link there, right? If you put the author's name, you can find all the links. Makes sense? You can find very clear each section. I'm just courtesy, I put the link there, but you can find all the links. It's all free access. Okay? Each chapter is there.
Thank you.
Then, guys, I read the layering part. I hope you guys think about it. We already played the layering first class, right? Talk about the TCP/IP, how many protocols there, how many layers there. Then typical SO, right? How many layers there? Please go back and read those chapters. Next time you will start with this quiz, okay? Because today we just no time. Okay? That's it, guys. Then the history part, you watch it. Then we will briefly explain the layering part and the service. We will go to the chapter 2. Okay? And you can do the homework. When you do the homework, you need to read the chapter 1. So you have something to do in the weekend. See you next Monday.